now let's get to the good stuff. We're going to start with Unit 1 now. Now, right away in Unit 1, you're going to see a quick review from Unit 0, talking again about an element. A compound, again, is when any elements bond together. Nothing new here at all. You've got, and remember that elements and compounds are what we call pure substances. And then you can have mixtures. Mixtures are not pure substances. You can have homogeneous mixtures that are uniform throughout. We often call them solutions, like when you dissolve salt in water. And you can have heterogeneous mixtures, like a chocolate chip cookie with distinct regions within the sample. Okay, moving on. Okay. Avogadro's number and the mole concept. So a lot of times in chemistry, we're going to use numbers that are really, really big and also numbers that are really, really small, which is why we use scientific notation. Okay, and one of the things that we use a lot in chemistry is called a mole. Okay, and you can see here that a mole is just that. Just like, and again, this is from regular chemistry, just like 1 dozen equals 12 whatever, 1 mole. And notice a lot of times it's abbreviated without that E at the end. So M-O-L-E, M-O-L-E-S, and M-O-L are all the same. 1 mole is equal to 6.022 times 10 to the 23rd, not 22nd, 23rd, whatever. Okay? Now, we're going to use this all the time. We're going to use moles a ton in dealing with chemistry. Okay? So that's what a mole is. Okay, and now let's use that to it kind of goes through a lot of details here. Okay, what we find here is that this right here, this is the important part right here, is this molar mass of the substance. Remember earlier in Unit 0 we talked about the atomic mass, and I called it also the molar mass. Well, here's again atomic mass again. Okay, in terms of the mass of the atom, if you have 1 mole of that element, whatever that element is, we can say that is equal to the mass. So 1 mole of, let's say, carbon has a mass of 12 grams. Another way we can write that is that carbon has a mass of 12 grams in 1 mole. So if you are given the grams of a substance, you can use the molar mass, this right here, and obviously we're going to flip it. We're going to put the mass on the bottom. We're going to put the 12 on the bottom here, 1 mole on the top here, and that will convert you to moles. Okay? And then you can do the exact same thing backwards. If you're starting with the moles of the substance, you can multiply by the molar mass of the substance, put the moles on the bottom, and get the grams. Okay, so let's do some examples here and kind of see what this looks like, as I feel like I always learn things better when I do examples. So if we have 84.2 grams of sodium phosphate, I'm going to take 84.2 grams of Na3PO4. And guys, whenever I do an example, I do the example exactly like I would do it on the AP test. Okay, and now I'm going to get my calculator out, and obviously I'm using my phone here, but on the AP test you're going to use a real calculator. So the molar mass of sodium is 23. I'm going to multiply that by 3 because there's 3 of them. And then I'm going to add the mass of phosphorus, which is 31. And then I'm going to add the mass of oxygen, which is 16. And there's 4 of them. So, and then I typed in a number wrong. And it equals 164. So the molar mass of Na3PO4 is 164 grams per mole. So again, if I have grams here on the top, I'm going to put 164 grams on the bottom, 1 mole on the top. And now I simply, again, go back to my calculator, and I go 84.2 divided by 164. And then I look at my significant figures here. That is the measured number in this equation. So the answer is 0.513 moles. Okay? And remember, a mole is not just this molar mass here. It's also that number, the 6.022 times 10 to the 23rd. So on letter B, we're going to start with 5.02 times 10 to the 24th molecules. And yes, there's no abbreviation for molecules. It's super annoying. So basically what we're doing is we're starting here, and we have to go from there to here, and then from there back to grams. Okay? So the first thing we're going to do, remember, a mole is the number of grams from the periodic table, but it's also equal to 6.022 times 10 to the 23rd. Remember from right here, 6.02 times 10 to the 23rd, whatever. So in this case, it's molecules because we're talking about molecules. So we can say there are 6.022 times 10 to the 23rd molecules in, what's that equal to? 1 mole of this CH3OH. And if the question asks us for moles, well, now we're done. Now we just take this, the 5.02, and divide by 6.022, raise to their correct powers. But they don't. They're asking for grams. So now my last step is to go 1 mole of CH3OH. And now to get to grams, I'm going to have to do this part again, where I figure out the molar mass of CH3OH. So 12 plus 3 is 15. 15 plus 16 is 31. Plus another 1 is 32 grams in 1 mole of CH3OH. And again, if we do that correctly, just like up here, grams on the top, grams on the bottom, cancel. Molecules and molecules, moles and moles. I know that I've done this problem correctly. So now I have to go to my calculator, and I'm going to go 5.02. Let's see. Trying to see if I don't see it here. Times 10 to the power of 24 divided by 6.022 times 10 to the power of 23 times 32. Okay, equals 266.7. Again, this has 3 significant figures. So my answer, 267 rounded grams. Now, as I'm doing this, guys, hopefully you're not just doing what I'm doing. Hopefully you're putting this into your calculator as well. And I'm setting a bad example. Don't use your phone for these. Okay, you absolutely are going to need a calculator for this class. So if you don't have one, just go get a cheap one from Walmart, $10, $8, whatever. Okay, but you will absolutely need one for this class. Okay, and then our last one here for these examples. Oh, no, sorry, there's a couple more. Okay, and on letter C, we've got 5.02, so that same number as before, times 10 to the 24th molecules. Okay, I just wanted to show this one time, because really what we're doing here now is we're going from particles over to atoms. So let me show you how to do that. Okay, because this is how many molecules we have, but they want to know how many hydrogen atoms are there in that number of molecules. Well, let's say I have 1 molecule of CH3OH. How many hydrogen atoms do I have? Well, there's the 3 plus 1 more makes 4. So I know that for every 1 molecule, there's 4 hydrogen atoms. So I can say that. That's my conversion right there, is that 1 molecule of CH3OH contains 4 hydrogen atoms. And that's it. That's all you've got to do to go from molecules to atoms. Okay, so now I'm going to take that number, again, 5.02 times 10 to the 24th, and I'm going to multiply it by 4. And that equals 2.01 times 10 to the 25th hydrogen atoms. Notice I'm writing my units for each of these. Again, not a huge deal unless they specifically ask for it on the AP test. Okay, this one's very similar, but now we're starting all the way back at grams. So this is a good one here that we're starting at the very beginning, and we have to go all the way. And what I mean by that is we're starting all the way here at grams, and we have to get all the way over here to atoms. So now might be a good time to pause and try to see if you can do it yourself, and then check and see if you get the same answer as me. And then and then you can verify and see what you did right or did wrong. Okay, so the molar mass of HC2H3O2 is 2456 is 60 grams in 1 mole. And I know that 1 mole of this is acetic acid, contains 6.022 times 10 to the 23rd. I need some more space because I got to write out molecules. And then I also know that 1 molecule of acetic acid contains, just like the one before, it also contains 4 hydrogen atoms. Okay, so that is the correct setup. So now I'm going to take 78.22. I'm going to divide by 60. I'm going to multiply by 6.022 times 10 to the power of 23. And I'm going to multiply by 4. And it should be a pretty large number, and it is. I get 3.1. Now, this has 4 significant figures. So I'm going to go 3.140 times 10 to the 24th hydrogen atoms. Okay, and then our last one here out of these is, again, just trying to give you lots of different ones. Try this one by yourself first before you watch me do it. But basically, we're starting at atoms. We're starting at the very end on the right-hand side. So we're starting down here this time, and we got to make it all the way back 2 grams. So basically the same process we just did in reverse. So 7.76 times 10 to the 22nd hydrogen atoms. And now, what did I do here first? I started with my hydrogen atoms. Okay, how many hydrogen atoms are there in here? Well, it's NH4, and there's 2 of them. So that means there's 8 hydrogen atoms all total. So that's 8 H atoms in one of those, and I'm just going to say particles this time. You can say particles or molecule, doesn't matter. Okay, and then we know that for every mole there are 6.022 times 10 to the 23rd particles, and that is equal to 1 mole. And then we can say that 1 mole, and notice it's the same process of above, just as in reverse, so everything's flipped. And now I need the molar mass of, this is ammonium carbonate. So ammonium is 18. There's 2 of them. That's 36. 36 plus 12 is 48. 48 plus 64. Make sure I'm doing this right. 8, 36, 48, 48. I feel like I'm not doing this right. 14 plus 4 is 18. 36. 36 plus 48. 45 is 96. 96 grams. Here's the nice thing too, is you just make your phone do it. Just say, hey Google, what's the molar mass of ammonium carbonate?
The molar mass of ammonium carbonate is 96.09 grams per mole.
Okay, geez, take it easy. Okay, 96 it is. Okay, and now I go back to my calculator, and I go 7.76 times 10 to the power of 22nd divided by 8 divided by 6.022 times 10 to the power of 23 times 96 equals, jeez, that doesn't seem right. I must have made a mistake there somehow. Yeah, I think I did. 7.76 times 10 to the power of 22 divided by 8 divided by 6.022 times 10 to the power of 23 times 96. How about 1.55? That sounds a little bit more likely. 1.55 grams. All right. Example 2, I'm going to leave that to you. I'm going to have you do that. Increasing the number of particles means get to that. You need to get all of them to this one right here. You got to get to particles. Okay, so if they're not there, you got to get them there. Okay, and then mass means which one has the smallest mass to the greatest mass, and then moles the same thing. It should, theoretically, all of those should be the same order. I'm going to move on here. These are some actually from old AP tests, so let's take a look at these. So example 3 says a new monoatomic element A. So first of all, anytime they use that, if you're like, wait a minute, where's A on the periodic table? A lot of times they use fake elements. Okay, they just make them up, like the letter X in math. Okay, so if you're like, well, I can't find A on the periodic table, well, because it's not there. Okay, so a new monoatomic element. So mono means one. So just that one element, not a diatomic element like oxygen or even nitrogen here. Okay, is discovered and is found to have a molar mass of 18 grams per mole. At high temperatures, this new element A reacts with nitrogen, which has a molar mass of 28 grams per mole. Determine the mass of 0.25 moles of Na2. Okay, so this seems as simple as, okay, well, they're giving us the moles, and they want the mass in grams. So thinking about that chart from earlier, we're at moles, and we just have to go back to grams. Okay, really the key is, what's the molar mass of Na2? Well, N2 is 28, and we know that N is therefore nitrogen, obviously by itself then, is 14. And A is 18, but there's two of them. It's Na2. So we're going to have to multiply that by 2. So 14 plus 18 times 2 is 36 equals 50. So this has a molar mass of 50. So if we have 0.25 moles of Na2, 1 mole has a mass of 50 grams. 50 times 0.25, using just those two significant figures, mathematically it comes out to be 12.5, but with two significant figures, we would round that to 13 grams would be the correct answer. And remember, on the AP test, you absolutely must show your work. Okay, please. If you just write 13 grams, you are not going to get the point. Okay, you absolutely have to show where does that number 13 come from. Okay, and remember, guys, during these videos, sometimes I'm going to make mistakes. And if I do, don't worry about it. You're going to do the calculations a few times. You're going to be like, this guy's an idiot. He did it wrong. Very possible. Okay, and if I do, just let me know, and then I can fix the video for later. Okay, last one here. Example 4. A new diatomic, so not monoatomic, a new diatomic element, A2, is discovered and found to have a molar mass of 52 grams per mole. At high temperatures, this element reacts with N2, again 28. Determine the number of grams in 32. The number, oh, you know what? I screwed up. It should say moles. Determine the number of moles in 32.2 grams of N2A. Okay, obviously, determine the number of grams. We already know the grams. It's 32.2. So, first of all, let's figure out the molar mass of N2A. So, nitrogen, again, is 14. There's 2 of them, so that's nitrogen. Plus A, again, A2 is 52, so that's 2 A's. So 1A is just going to be 26. So 14 times 2 is 28. 28 plus 26 is 54 grams per mole. So now it's just 32.2 grams, 54 grams in 1 mole. And the 54, you don't need to show. I did. I showed where it came from. You don't necessarily have to show where that came from. That's not a huge part of this problem. So now I take 32.2, I divide by 54, and with 3 significant figures, I get 0.596 moles of N2A. Okay, and that is it for our first lesson.